Good morning, everybody. We are here back with aim number 2, and we're going to start rewriting expressions with rational exponents. A lot of you don't know this word, rational. Okay, when you're talking about rational exponents, all it really means is fractional. Okay, so when you look at your do now and you're being asked to raise 9 to the 1/2 and 36 to the 1/2, that's not something you guys should probably know immediately. So if we go into GeoGebra and I do 9 to the 1/2, okay, I get 3. And if I do 36 to the 1/2, I get 6. Okay, so here we go. In this, we get 3, and 36 to the 1/2 is 6. So think about raising a term to the 1/2 power. What is it the same as? What operation can you do to 9 to get 3? What operation can you do to 36 to get 6? Hopefully you said it's the square root of 9 and the square root of 36. So literally, raising a term to the 1/2 power is the same as taking the square root. Okay, so I just want you to take a look and evaluate the square root of 9. Can you figure out potentially where the 1 and the 2 come from? I bet most of you don't understand that there's really a little number here and here. When you call it the square root, this really means the second root, right? That's your 2. And where does the 1 come from? It's your power, which you don't see there, okay? So if we wanted to evaluate this 4 to the 3 over 2, well, here's what you have to know. You have to know that your 3 in the numerator is going to represent your power. And in your denominator, your 2 is going to represent your root. So if I go back to the calculator and I do 4, and I'm going to raise it to the 3 over 2. Okay, see the number I get? 8. Okay, so now let me show you. 4 to the 3 over 2, your answer is 8. And I'm going to prove it to you. If I know my root is 2, and remember, I don't technically need to put the root of 2 because the square root is that root of 2. And I'm going to raise it to the 3rd power. Okay, so that's one way I could show it. Do you know what 4 to the 3rd power is? 4 times 4 is 16 times 4 is 64. So that's really the square root of 64. And the square root of 64 is 8, which is exactly what we got. Now, another way you could do that is take the square root of 4, just like that, and cube it. So nothing changed. Our root is still 2, and our power is still 3. Well, the square root of 4 is 2. And if I cube 2, I get 8. So if you notice, there's 2 ways to write it, and I'm going to show you here. In order to express x to the n over m, which again is the power over the root, you could say it's the m root of x to the n power. The other way you could show it is with parentheses. It is the exact same thing as showing the m root of x and that whole thing raised to the n power. Okay, so that's a lot to take in right now, but probably the most important thing, you're going to hear this over and over and over again, that n represents your power and m represents your root. Okay, so we're going to just do a little practice going back and forth and figuring out how to work back and forth. In other words, taking a base x with a fractional or rational exponent, 5 over 2, and writing it in simplest radical form. Well, here's what you have to remember, that the 5 is the power and the 2 is the root. So that means it's the square root of x raised to the 5th power. Okay? Technically, that's not in simplest radical form, but for now, I'm going to leave it just like that. As long as you guys can get it into that form, I'd be very happy. But I just want you to remember there was another way we simplified this. When we said, okay, let's simplify the square root of x to the fifth, you needed the biggest perfect square. Nick Golden, you were so good at this. What is the biggest perfect square that goes into x to the fifth? I would break it into two radicals. X to the fourth, because it's the highest even number that goes into x to the fifth. And then we'd have an extra x left. The reason you pull out that x to the fourth is because any perfect square, any even exponent is a perfect square. So the square root of x to the fourth is x squared, and you keep your radical x. So technically, this is simplest radical form. But for right now, I would accept that. Either of these is acceptable. Okay, let me try another one. So if I have x to the 3 over 8, the 3 is the power. The 8 is the root. So now, again, this little thing right here technically has a root of 2. It's called the square root. But if there is a number there that you now know is not 2, you're going to use 8 as your root. It's the 8th root of x to the third power. So I want you to understand that that little 8 is called the index. This is the index or the root. Okay, and notice where it goes. It goes inside that little radical thing, okay? It doesn't have it's not a big number 8 outside of it. That would be 8 times. This is a little teeny tiny number and it's showing the root. Okay, I'm going to leave that last one for you, letter C, and I'm going to go to the next part. In number 2, they want you to now rewrite using only rational exponents. So now it's going the opposite way. I have, once again, taken note. This is the power. This is what we call the root. So if I know my base is x, it's power over root. Remember, power over root. Power is 2 over the root is 7. That's it. You just rewrote it using a rational exponent. So try the next. Actually, I'm going to make you try B. I want to do C with you because I think C is a little bit trickier. I know you'll all see that your exponent or power is 9. But what's the root? It's missing. What's that number when it's not there? It's actually 2. It's the square root. Okay, your square root is equal to 2. So this has a base of x, and the power is 9 over the root is 2. So remember, so important, when you don't see a root in your radical, it means it's 2 because it's the square root. Okay, I'm going to leave you C and B to try on your own, but let's go back to these. Let's try number 3 because some of these are tough. In number 3, you're going to do operations, and then you're going to rewrite in radical form. So they want it in radical form, not in rational exponents. So in letter A, I should say, in number 3, this is, and maybe make a little note for yourself, this is the product rule. So these are your rules from your first lesson. And your product rule states you are to, when you see multiplication, we add exponents. Okay? So that means we keep our base and we take 1/5 plus 2/5. So that would be x to the 3/5. Now, we don't want it in rational exponent form. We're going to rewrite it in radical form. So that means we're going to show with power and root, which means the root is 5. It's the 5th root. of x to the third power. Okay, that's your answer in radical form. Okay, let me try another one with you. I'm going to go new color. So if you look at B, B is what we call power to a power rule. See how the exponent is raised to another exponent. Here is where you are allowed to multiply exponents. Does everybody see the difference? In letter A, you are multiplying, we add exponents. But in letter B, it's a exponent raised to an exponent. You're allowed to multiply them. So that's x to the 3 over 2 times 3. To make your life easy, put that 3 over 1. And now when you multiply, you should get 9 over 2. Again, I'm going to remind you, your numerator is the power, your denominator is the root. Okay, now I'm not going to mark you wrong, but that means it's the square root of x to the 9th. So I am not going to show that little index of 2. We never do that. It's like we don't show a exponent of 1 or a coefficient of 1. Okay, so I'm going to leave letter C for you guys to try. Okay, let's go down a little bit tougher. Let's talk about letter B. So in letter B, it tells you B is greater than 0. Okay, that means your base is greater than 0, and D is a positive integer. That means your exponent is positive. They want you to write this expression, 3B to the 2 over D is equivalent to which one? Okay, so let's just talk about your choices. Everybody take a look at your choices 1 and 3. Does everybody notice that 1 and 3 is 1 over? Does anybody know when your answer would be 1 over the d root of 3b squared, or 1 over the square root of 3b to the d? So you should understand that these two, this one and this one, okay, are when you would have a negative exponent. Okay, that makes it turn into 1 over something. And this is telling us that D was a positive integer, which means your 3B raised to the 2 over D is a positive exponent, which means your exponent was not negative. Now remember, your 2 is your power and your D is your root. So write it. It's the D root. Sounds weird. Now, very important. Take your whole thing. 3b, that whole thing is being raised to the second power. Now, you don't see that answer there, do you? Not exactly how I wrote it. But remember from the beginning, you could write it like this, or you could show the D root of 3b and that whole thing squared. So that's why your answer is choice 4. Okay, they are equivalent. Understand that. Okay. Okay, I'm definitely going to do the next couple with you. Some of these are tough. Let's look at number 5. It says for which expressions are equivalent to, now look at these words, 1 divided by, so I'm immediately going to write that. 1 divided by the 6th root, the 6th root of x, okay? So that's what we're working with. That's what they want. Which of those would describe 1 over the 6th root of x? Okay, so I'm going to start out with the first one. I guess I'll use my pink. Okay, and I'm going to do choice 1. So look at choice 1. It's the 6th root of x divided by the cubed root of x. Okay, and for me to simplify this, you know what I'm going to do? I'm going to turn them back into rational exponents. Okay, in other words, I'm going to take x and raise it to the power over the root. Now this is interesting. What's the power here at x? Do you see anything? No. So what's that exponent if we don't see anything? It's technically a 1. So it's a power of 1 over a root of 6. Okay, do the same thing with this other one. The one in the denominator has no power again. So it's x to the power over 1 is the power over the root of 3. Okay, so now we have x to the 1/6 over x to the 1/3. Interesting, everybody look at choice 2. There it is. That's the same. But now let's just make sure that's really equivalent. Seems to be equivalent. Well, let's see. Keep going. This is the quotient rule, okay? I'm going to make a little note right here. Quotient rule. What does that mean? It means to keep your base, subtract exponents. Okay, so that means x to the 1/6 minus 1/3. So I'm going to go to the calculator. Let's take 1/6 and subtract 1/3. So I'm going to do 1 divided by 6 and subtract 1 divided by 3. Okay, and look what I get. Negative 1/6. I hate when that does that. Okay, so when I subtract that, I get these two here, hold on, gives me, what happened to my pen? Hold please. Oh, what happened to my pen? Hold on, let me just check. It shouldn't be. Yeah, I'm connected. Why? Sorry, technical difficulties. Won't let me switch. All right, I might have to stop there, guys. So weird. All right, I'm going to pause here.